That's how we make an entrance.
Well, good evening, everybody. How you doing? It was a ass-long day, right? Still have the energy to do some more stuff? Like to do something? All right, so I'm Pascal.
I'm Jeffrey.
We will take you on a bit of a journey into the world of rapid prototyping, and if that doesn't really mean anything to you, don't worry. By the end of this 19-minute session with us, you will know exactly what it is because you will have experienced it. Before we get there, super important, every table, just look around and count and see if you get to 6. This table here, you have a shortage of 2 people. So please do me a favor. Make sure that because here's the thing, we will divide you up into teams of 3. I need to have 6 people at each table so that this can actually work. So if you're all my friends in the very back here, there is no hiding. Come to the front, join us here. We got a table which needs 2, you guys need 2 here.
If you're short, raise a hand.
Indeed.
So we can move somebody up.
And my friends, this is an old presentation you're just pulling up, not the one which we sent you. That would be awesome.
It's like that one, but
this
better.
one, yes.
Yeah.
There we go. Okay. So do me a favor, sort that out. You are adults, you can do this. And before we get started, before we get into this world of rapid prototyping, I want to maybe acknowledge something because you've been sitting in this room now for about 2 days. You've soaked in a lot of information. And if you're feeling a little bit like my feline friend over here, so you're getting ready to jump. You're taking in all the information, everything you heard, all this stuff, the people here on this stage give you everything you already know. You're getting ready to jump, and one more piece of information, and if you're feeling like this, trust me, that is absolutely normal. Both Jeffrey and I have spent a lot of time inside of these holy hallways of singularity. We know where you're coming from. Today, we want to help you to actually make that jump.
We do, and no matter how many times I watch that video, every time I think maybe today's the day that the cat's going to make it. Today
also,
the cat didn't make it.
No cat was being harmed in the making of the video, just so we're clear, right?
But yeah, so we want to take a leap with you. We want to take a leap a little bit from kind of knowing to doing. That's what we're going to talk about. And so I'm going to ask you to do some things. The first one is really easy. I want you right now to cross your arms in front of you like you're bored. I know you're not really bored yet because we just got started. I would never do this at the end of the session. Okay, great. Now, without looking down, I want you to recross your arms with the opposite arm on top. Yeah, I hear some laughing. Some of you are like looking down at your arms like it's a weird knot I asked you to tie. And it probably feels a little bit weird to recross them because all of us have a way that we're established in doing even that simple thing. We get into cognitive ruts very easily, very often, and very often without realizing how deep they are. And it's hard to think your way out of a cognitive rut. The easiest way to think your way out is to actually do the thing, to embrace a little bit of what we call embodied cognition. And that's kind of what we're going to get into today, this idea of doing to arrive at the knowing, to learn by doing. And that is indeed the best way to learn. That's the easiest thing I'm going to ask you to do so far. We're going to get a little more complex as we go.
Yeah, indeed. And so our work really started about a decade ago. So I am, as you heard, and you might have heard in my accent, I'm German. I moved to Silicon Valley about 15 years ago in tech. And I was really fascinated by these ideas and these concepts which these big companies, the Googles of this world, actually deploy. And I wanted to figure out what is it which makes them successful. And a way for me to do this was I worked for a couple of them, basically to open the door, open the kimono, look underneath the kimono, and figure out what's actually happening. And as part of that research, we started asking people. We said, what is it which makes you successful? And you had all these ideas. And I'm pretty sure you heard many of those. It's you need the right team, you need the smartest people in the room, and you need to have the right processes in place. But what we did was we found only one common denominator, one, of all of the companies which are super, super successful, the Googles of this world. And that really comes back to effectively what is beautifully expressed in this very old quote by no other than Winston Churchill. Winston Churchill once said that success consists of going from failure to failure without a loss of enthusiasm.
This is also the most British thing that anyone has ever said.
100%, stiff upper lip.
Top 5 at least.
But what this is about is the question of how do you actually deal with failure? And if you've come to Singularity, by the way, you will get the slides, of course, like, so no need to take the pictures unless you want to put it on social media. But if you come to Silicon Valley, this is the campus of our friends over at Facebook, or not our friends, depending where you stand on that equation. But you heard a Silicon Valley mantra being repeated over and over and over again. I'm pretty sure you heard this. Fail fast, fail often, fail forward. Now let me tell you once and for all that this is utter bullshit. It's utter bullshit, because here's the thing. Who likes to fail? Nobody, exactly. If I put you, like, regardless how many Failure of the Month awards I give you, and I put you on a stage at the company meeting and say, here's Pascal, he's the biggest failure of the month. Congratulations. Like, nobody likes that. Also, show me the one company in the world which actually was successful by failing. It's just not right. I think we're doing failing wrong. And this is the first part we want to teach you, which really is, for me, is this idea that we have to rethink failing. And I invite you to use an acronym for fail. Instead of thinking about failing as failure, use it as an acronym as your first attempt in learning. And this is important. You might look at this and say, well, Pascal, these are only semantics, right? Fail, learning, that's the same thing. It is not. Because when you look at the neuroscience of failing, there's something really fascinating happening. When you look at a failure, let's say you, your child, like your spouse, your coworker, you look at something and you define it as a failure. You say, we failed. What happens in your brain is that you anchor this at what we like to call a dark spot. The part of your brain which gets activated when you think about failure is the amygdala, the oldest part of your brain, the fight or flight part of your brain. And it kind of makes sense, right? Because back in the day, when we were hunters and gatherers, and we roamed the savannah, and you saw a blueberry, and you pick up that blueberry, eat the blueberry, and it makes you sick. The next time you see a blueberry, of course you don't touch it anymore, because it made you sick. It's survival. The problem is that our brains haven't evolved since, at least that much, since we moved on from being hunters and gatherers. So today you're sitting in a meeting, and someone says, I have an idea. And I guarantee you, there's a person typically in a aubergine-colored suit. We call them the aubergine people, or for Americans, eggplant people. That person will say, oh, we've tried this before, it doesn't work, kid. Heard that story, right? It's the same part, because you anchored it as failure. Now here's the fascinating thing. The moment you anchor it as a learning, so you focus on what are the 5-10% of even the biggest failures, what have we actually learned? What you do is you create a bright spot in your brain. The part of your brain which gets activated is the prefrontal cortex, the newest part of your brain, the part of your brain which is responsible for creativity. Because ultimately, creativity is nothing but the combination of bright spots, right? It's this idea of, I tried this here, and it kind of worked, and I tried this here, it kind of worked, and I've got this piece of information, and I bring those together, and that's how I create something new.
Yeah, and so what we're going to be giving you, what we're going to be working with today is actually building this into a system for more effective learning. And the failure is a key piece. And I'll share two things that I think are interesting here. The first is that in other domains where we have these kind of evolutionary processes where we're progressing through something gradually, we don't talk about failure. Like if you're training for a marathon, running 18 miles, that's not a failure. That's part of your process. That's recognized as part of the build. Same thing if you're learning a musical instrument. Same thing, hopefully, if you are parents, you don't emphasize failure with your little ones, right? It's all part of a process through which they learn. The second thing that's interesting here is that we can see in both biological and artificially intelligent systems that they actually learn most effectively when they struggle a little bit. They learn most effectively when they're making mistakes. So if you go through your innovation process, your creative process, whatever processes you have, if you're not making some mistakes, if you're not having some of those moments of failing, you're not maximizing learning. So what we're going to work on today is building a system to maximize the learning value of what we might consider to be a failure. Effectively, we're going to make all of you smashing successes at failing the right way.
Indeed. And we have a set of pirate rules. So now we're getting into the doing, because this is about doing it. So we have a set of pirate rules, and what we're going to do for the next hour with you is we're going to give you a little bit of a system, an explanation, and then we have you experience it. And you will see it will feel very compressed, and that is on and by design. And then we give you a little bit more information about like, how do you do the next step, and then you're going to do these steps. All of this is based, literally based, on the best prototyping system we could find in the world, which is the system which was developed by Google X, or now Alphabet X. So the fabled moonshot factory over at Google, where I had the great pleasure of somewhat working with them when I was over at Google. We have lots of friends over there. So we brought this out of Google, brought it into many other companies, organizations. So we get you to do stuff. You see there's a big box of like magic, weird stuff on your table. You will use that box later. And Jeffrey, what do you think? You good to go?
Yeah, I think we should get into the first step. And before we do that, though, because I understand what happens, I've been doing this kind of stuff long enough, when you cut people loose to do a thing, it's really hard to bring them back. And Aaron has told me a little bit about the struggles he's had bringing you back from interactions and activities. So I want to make sure that we're all in agreement. You all do this raising your hand thing? That works? Okay, not really. All right. All right. So we're going to see how well it works. We're going to give you a preposterously short amount of time for this first step. And at the end of that time, we're going to try this hand raising. I'm going to see if I can bring you all back together. And if it doesn't work, I'm going to resort to my own methods in later steps. And believe me, I have a deep bag of tricks. So we'll see how it goes.
Perfect.
But let's go ahead and do a thing.
Indeed. So if we want to prototype something, we need to have something to prototype.
That
What we're
helps.
going to do is, or else, what we're going to do is, each table, divide yourself into two halves. Imagine there's a dividing line through your table. You should have 3 people on the left and 3 people on the right side. The people on each side, the 3 people, you're one team. You work together now.
I want to say first, before you break it up, whichever team you're on, that's the best one. So be thankful and don't worry about the people seated next to you.
Absolutely. And what we want you to do is, and we give you 3 minutes for this. I told you it's going to be hard. Think about a problem you care about, a real world problem. Think about something you can actually prototype. So don't come to me and say, the war in the Ukraine is something I care about, I want to solve this right here, prototyping 30 minutes. That ain't gonna work. World hunger, similarly. But if you want to solve, for example, you had issues when you checked into the hotel, like I did, and they couldn't run my credit card because they were too fumbly with their keypads and whatever, that might be a problem we can actually prototype. So what we want you to do is, each group, think about a problem you are curious about, you want to prototype today, right here, and then agree on it. So we give you 3 minutes, turn to your neighbor, figure out what the problem is, time is up, and we'll get you back in 3.
All right, friends, that is your time. Oh, I think you're changing your behavior to try to make Aaron look good now. Okay, all right, so that worked pretty well. Now, I'm a little curious what they came up with. You want to hear a couple of these?
Absolutely. I would love for 2 or 3 tables to just very briefly share out and shout out which problem you want to solve.
Bring it. What do you got?
We want to fix the key to the elevator of the hotel.
Love it!
Yes!
Yes!
You have lots of backers. I have funding for you, my man. Okay, that's a fantastic one. I love it. I feel like a therapist. I want to hear
Yep.
all your problems. Table
Here.
4.
Table
Yes.
4.
We want to reduce food waste at home.
Your personal home? Like in your house?
In our house.
Everyone's houses.
Yeah.
Do you all live
Perfect.
together?
So
Not yet. Not yet.
Yeah, it's
This
early
comes-
in the program. Okay.
There's a whole week ahead of you.
Other half of table 4?
We'd like to make Singularity University sessions registrations better.
Make what?
The lines outside, I say, man, it's so technological nowadays, we can make this better.
Okay, perfect. Let's get one more over there in the back. I see you guys are like, please, me. Affordable homes. In the interest of prototyping this right here, right now, I would encourage you to make this a tiny little bit more specific.
I mean, that said, whatever home you can build in the next 40 minutes is going to be very affordable.
Yes, by definition. And probably over here, you have your hand up here. Can you just... Cordless furniture that charges iPhones. All right, we'll see.
Sign me up.
Sign me up and we will see. All right, so This was step 0. We haven't really begun. We just needed to have a problem, of course, to start with. We're getting going. And as the one great Leonard Bernstein once said, to achieve great things, 2 things are needed: a plan and not quite enough time. We have both. Because we are going to prototype affordable homes, a solution to the elevator key disaster, household waste or food waste within the next 30 minutes. So you're going to be like seeing, and this is not just a joke, like there is method to this madness. There's reasons why we're doing it the way we're doing it, because truly that is the way we prototype. And with that being said, let's get you going.
Yeah, let's talk a little bit of method. So Aaron kind of queued you up with this idea that all of this comes down to experimentation. That's really what we're talking about. We're talking about experimentation to drive rapid learning. And so you want to have a good system for designing an experiment. So that's kind of what we're going to get into now. This is the method. This is the system. And it starts, of course, with some steps. We're going to talk about formulating a thesis, formulating a hypothesis, prototyping and testing, actually building the thing and learning about it, and then, of course, that learning and learning again. So those are kind of the steps we're going to go through one by one experientially. And for everyone, we're going to give you a little bit of content, a way to think about the thing, and then we're going to have you do the thing so that you actually learn through the doing.
Absolutely.
Yeah, so let's go ahead and start by talking about a thesis. And to formulate your thesis, there are really 2 key pieces that we want to address to do this and to do it well. And we're going to suggest that when you're formulating your thesis, your understanding of this problem, that you want to argue from first principles, and then you want to address the 4 Ps. First, arguing from 4 principles. This is a very, very, very old idea that actually goes all the way back, like 2,500 years, to Aristotle. And essentially what we're talking about here is the idea of arguing or reasoning from the first basis from which a thing is known. So what we're talking about is getting down to the things that you absolutely fundamentally know to be true. And that sounds pretty straightforward, but more often than we probably realize, we're actually operating on inference. We're operating on assumptions. We're operating on things we believe to be true, things that we feel reasonably sure about, but they're not actual certainties. They're not actually the ultimately soundest first principles from which we can base all of our further reasoning. And like I said, this is an old idea, but it actually is kind of a current vogue right now, particularly in the startup community that's largely associated with none other than, of course, Elon Musk. So we're going to give an example, a story from Elon Musk and Tesla that emphasizes the power of first principles thinking. And the idea is basically this. The story, in short, is in the early days of Tesla, when they're thinking about building their business and they're looking at the material inputs, one really important piece, of course, is having these lithium-ion batteries and having a whole lot of them. So Tesla goes out to see, well, how much are these things going to cost? And what they come up with when they go to some of the global manufacturers of these batteries is a figure of $700 per kilowatt hour, which, if you're planning on using a whole shitload of these, is a little bit of a problem, because that's a very, very expensive material input. Now, here's where I think, one of the many ways, that Elon Musk is maybe a little bit different from a lot of other leaders. Many business leaders, at this point, they're given a figure, and they say, well, okay, this is what I've heard, this is what I'm working with, so you have your price, now let's talk about how we can negotiate. Let's see what kind of deal we can arrange if we're going to do this thing at scale. Let's see if we can drive down that price from that first figure that you've told us. Now, that's one way of doing this. A different way that demonstrates the power of first principles thinking is to actually ask ourselves, well, what can we fundamentally know to be true about the material cost here, about what that price point should be? And one thing that we can do is actually look on a materials basis at what actually goes in to producing these batteries. And you can get that bill of materials and see what all the component pieces are, and you can come up with a different number. What does it actually cost to produce these things? And the figure that Tesla came up with was something far lower, $70 per kilowatt hour. So that suggests then that either there are some gross inefficiencies in the way that these things are being produced and brought to market, or that someone is making a huge amount of money in the middle. And so Tesla finds the opportunity that they could actually be producing these batteries themselves, put themselves in a very advantageous position, but they only realize that opportunity by arriving at a thesis based on reasoning from first principles, from that bedrock certainty.
Absolutely. So again, ask yourself, when you're thinking about food waste, for example, and you're thinking about starting to think about the thesis, the proposed solution, ask yourself, what do we actually know to be fundamentally, essentially true? And again, many of us, we use mental shortcuts, like cognitive shortcuts. We jump to assumptions. And often that's fine and good because it gets us to the goal quicker, of course. But very often we also overstep something. We go from like, here, $700 to 70. That's part one. And part two is, when you think about your solution, your prototype, think about and address the 4 Ps. The 4 Ps, of course, is marketing lore from like 40 years ago. The 4 Ps, unfortunately, don't stand for Pascal, 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 Pascal. That would be very funny. You might remember the 4 Ps is product, price, promotion, and place. And the important part here is this. We all have a tendency to address a problem from the basis of what we know. Where are we strong at? If you're an engineer in Silicon Valley, how do you solve a problem? You solve it by engineering. If you're a marketing person, you think about, hey, what can I do in the marketing world? What you should do, though, is consider the problem holistically. Look at it from all angles. Say, where can we actually change and play with all of those 4 dimensions? What can we do in terms of changing the product? But also, what could we do in terms of the marketing or the pricing? And very often, when you look at these disruptive solutions which come out of Silicon Valley, the ones which are really disruptive, they play in multiple dimensions. So think about the multiplicity of these dimensions. Now, with that being said, we have another task for you because we want to get started. So you all have, in your group of 3, picked a problem. I hope it's a juicy one you're excited about. I hope it's not too juicy, as in like solve homeless crisis or like, that will be hard to do, but I'm curious to see what comes out of it. And now, as a next step, as our first step, so to say, in this journey, we want to now do, effectively, a step where we take our problem and we refine the problem. So we pick our problem as a group, we agree on the problem, and now we're taking the problem, the thing we want to prototype, and think about how do we actually approach this thesis from a first principles basis. What do we know to be true about this thing? And how can we probably incorporate some of those P's which we haven't thought about, which don't come natural to us. And we want to give you another 4 minutes. 4 minutes. It's going to be short. And really, this is the step where we get you to formulating, here's the thing we actually want to try out. Here's the thing we want to build. So you have the problem. Now we get to this point where you say, this is what we actually want to build. This is the overall prototype, our proposed solution, our idea how we can tackle this. And you refine it by going into first principles, and you think about the 4 Ps. 4 minutes, time runs now.
All right, friends, that was 4 minutes. If you can hear me, raise your right hand and put it on top of your head. And now if you can hear me, take your left hand and put it over your mouth. Oh yeah, it's crude but effective. It does work. All right, awesome, welcome back. I know that was super, super short, preposterously short amount of time. We weren't trying to get you to solve the problem. We were trying to give you a way for thinking about how to effectively understand it. So we want to check in with a couple of the tables that we talked to the last round and see, do we really understand what is the problem that we're approaching here? And then what might be the opportunity that we see to actually think about brainstorming a solution, which we're going to get into when we talk not about the thesis, but the hypothesis. So Pascal, can I run you around the room to check in with some people?
Absolutely.
All right.
On the floor.
Yeah. So let's check in with a couple of our groups that we talked to.
Our food waste people.
Yeah.
Right, so the original problem is how can we reduce the food waste at home? We have tried to find out or to refine the definition of the problem.
Yeah.
First approach is that there is a gap between the needs and the purchase. We have gone further into the detail, and the gap is not really between needs and purchase, it's between needs and purchase of fresh foods and over-preparation. I mean, there is a three-step process: purchasing, preparation, and the real need.
Great, so you're kind of defining the steps of this process that you're now looking to see where are the inefficiencies that create the waste. So this is exactly what we're talking about, really understanding what is the problem space and what are the things that we can know for sure about it. Great, yeah. For 4 minutes, I think that's the kind of progress we want to see. Nicely done.
Do you want to hear about the elevator card key?
Of course
Because
I do.
that
I have
really
the same
annoyed
problem.
the heck out of me. This
I'm
is
also
you guys,
trying
right?
to back that project with my immense funds.
Yeah, so the problem is having a frictionless ride to your floor. Okay? Getting to your floor without
It's a beautiful
without
dream.
a problem.
Yes.
And then we analyze. Sorry? That was the other option. Then we already have two proposals. But yeah, that was the main problem, or how we see it, and then we're questioning the fundamentals, which would be why using a card at all with the magnetic or the reading card thing.
Yeah.
Perfect. All right, Jeffrey, do we want to get into the hypothesis? We have no time to lose.
Let's drive it forward. Okay, so now we're going to talk, now that we understand the problem space a little bit, we have a sense of what is out there, what the pieces that we're working with are. Now we're going to talk about formulating an effective hypothesis. And this is a really important piece of experiment design. It also is an essential step in effective prototyping. And what we're going to try to teach you to do here in just a minute is what we call tackling the monkey first. Now, you work with Pascal long enough, sooner or later he asks you to tell a story about a monkey. So that's what we're going to do. And this builds on a thought experiment that we learned from Astro Teller, who was the captain of moonshots at Google X. And so he's running some of the most effective prototyping processes and teams in the world, so he should have a pretty good way of thinking about it. And he uses the thought experiment to make a point that I think is important for all of us. And the idea is this. Imagine that you have decided that you want to train a monkey to, yeah, it's a great idea. Train a monkey to cite Shakespeare from atop a beautiful marble pedestal. And you believe that this is the key to all of your future fame, fortune, and opportunity. You're going to travel the world with this monkey. It's going to be an amazing thing. Or maybe people will come to you to see the thing. And so the question then is, if you have this brilliant idea that's going to make you a legend worldwide, you and your monkey, how do you actually start putting this beautiful dream together? And for most of us, probably what we start with is, I want to build that pedestal, right? I know how to build a pedestal. It's not that hard. I could chisel this thing out of marble, or at least I could probably learn how to do it. But that is exactly the wrong way to go about it, because that's the thing we know we can do. And at the end of the day, if I built this beautiful marble pedestal and sunk years into learning to be a great sculptor, and I can't actually train a monkey to cite Shakespeare, then I don't really have anything worthwhile or of value. On the other hand, if we can break that cognitive routine of going for the thing we know how to do first and instead find the hardest piece, the most uncertain piece, if we think about all the things that we're not sure about, all the assumptions, and then all the things that are really important, and then find where is the overlap there, the most important thing that everything else depends upon, that we're also taking a big leap, that is the monkey, and we should tackle that first. Because if you can train a monkey to cite Shakespeare and you never get around to building a pedestal, you still have a pretty cool monkey. And you might find that somebody just buys that monkey and they realize the vision for you, and you never even needed to do the other thing. But it's really important to actually start with the hard thing. Do the hard thing first. And this is not just a parable, it also actually shows up in the prototyping process at Google X and helps them be really, really good at breaking down problems and understanding, is this something we can actually do and we can carry forward? Does this make sense? Which means you also know when to kill a project. And so one of the famous examples is when they're looking at a big vertical farming initiative, and they're thinking about all the many, many things that you could do in designing and scaling vertical farming. There are a lot of things that you could work with, but they found the most essential thing they needed to know was, is this something that is actually viable, not just with leafy greens, which we know we can grow on vertical farms, but staple crops like maize. And so what they do is find the cheapest, quickest, most effective way to test that. That is the monkey to tackle. Not all the things that you could do with the design of the space and the lighting and the building and all of the systems inside, but is it actually viable for us to produce this most essential element? And it turns out their answer was no. And so they decided to kill this project. That vertical farming is great for growing kale and marijuana and maybe some other things like that, but it's not going to grow you the staple crops that they really needed if they were going to carry this thing forward. And this pops up other places as well, of course.
Yeah, absolutely. So I tell you a personal story. I used to work at Mozilla, the maker of the Firefox web browser, when Mozilla was 500 million users and actually king of the hill. And I used to run the innovation lab. So I had about 20 like super smart engineers, truly some of the best people I've ever worked with, working with me. And here's what happened. Like literally it's happened every single time. So we came up with another idea. We said like, hey, let's try this thing out, right? Our job was to invent the future. So you come up with something interesting, and then here's what happened. This is, I kid you not, this is a true story. So you sit in this room, and someone like, comes up with the idea, and then someone says like, this is cool, we should do this. All right, we need a project name. Because every project needs a cool project name, right? Like group identity, psychology, like we know this, right? So we come up with a cool project name. So now we're like, whatever, Project Jaguar. Now someone says, wow, we've got a project name, we need the domain for that, right? So we spend about a day like, figuring out which domain. It's hard to get an internet domain these days, whatever. So finally we get the domain. And then someone says, man, we've got the project name, we've got the domain, we need a logo. And so it's like, we go off to the graphics department, we're like, hey, we're like Project Jaguar, we need a super cool logo. It's really important for us as like a team, like team bonding and stuff. So a week later, we get this super cool logo, and then what does someone do? Because we're in Silicon Valley, T-shirts. So 3 days later, like someone like goes off to the T-shirt printer. 2 weeks, I swear to God, this happened to me all the time. It's 2 weeks after we started the project. Everybody runs around with a cool T-shirt with like Project Jaguar logo on it. We haven't done squat. We have done nothing. But that is what is the problem, right? Like we have a tendency to do the things we know how to do. How many times have you tried something where you're like, that you want to try something out, and you're like, let me just get the stuff I know how to do quickly out of the way, because then I can focus on the problem. And what we want you to do here is really figure out what is the monkey, what is the actual problem. So your next step is, we want you to actually sit down as a group and think about what are the things in the steps. You're not prototyping a solution quite yet. But what are the steps in this process we are working through to solve our problem? And which of those steps has the highest uncertainty? Which of those steps is paramount? If that step doesn't work, the whole rest will just fall apart. For example, in your keycard example, you could come up with saying, well, we could make the keycard electric, or we could use an NFC chip, or we could use a phone. You know how to do that. We know it works, right? So do you need to prototype this as a first step? No. Identify what is the monkey, because that is the thing we then want to create solutions for and want to prototype for. Another super short 4 minutes. You see a pattern emerging here. So not enough time, but a plan, and great things will emerge. So figure out what is the monkey. Go through all the steps. Think about like when someone goes through your proposed idea, like what is the pain points and what are the ones which you need to prototype. 4 minutes.
All right. Raise your hand if you want a Project Jaguar t-shirt. Yeah, of course you do. I'll tell you where you can find them online later.
Wonderful. All right. So by now, just as a quick recap, what we've done within effectively 10 minutes of time of you working is we have thought about a problem. We have refined our problem by going back to first principles, arguing up from the bottom of what we actually know to be true. We have hopefully applied the 4 Ps to look at the problem in all its dimensions. And we have now gone and said, okay, so what are the steps inside of our problems? What are like the pieces of it? And which of these pieces, or which of this specific piece is our monkey? What is the thing we actually want to prototype? What is our hypothesis? Now we're getting into the world of prototyping and testing. And in the world of prototyping and testing, we will go through, and again, we make this super interactive, 4 pieces. The art of prototyping, the science of testing, and the relevancy of questions. The art of prototyping is our first step. This is where we're getting you to do the actual hard work of building a prototype. This here is me wearing a Firefox costume. So I moonlighted at Mozilla as the official Firefox mascot, probably because I'm like 8'4" tall or something. I'm also, if you know anything about people in mascots in costumes, you know that I would get fired immediately from Disney because I'm out of character. I'm not wearing the hat at the moment, so that would be like, that's a cardinal sin. But I mentioned to you, I used to run the Mozilla Labs like rapid prototyping testing innovation unit. And here's what happened when we tested, when we created a prototype. And this is a little bit of a pitfall. It's another one of those beware stories. So we're sitting around a table. I sit around with my team around the table, and they're super smart engineers. So we come up with a thesis. We refined eventually, after we got the t-shirt, we finally sit down, right? And we're like, okay, we're done now, let's do the actual work. So we're sitting there in our t-shirts, and we talk about what could be the hypotheses be. Like, what is the thing we want to prototype? And then because I've got incredibly smart engineers working for me, what do? They say, hey, Pascal, I know how to do this. Like, I have an idea how to program this. I have an idea how to create a prototype around this. So what they do is, because there's a software, they open up their prototyping environments, their software environments, they start writing code. Now, what happened is the following. We create, there's a slide missing here. Oh, weird. Okay, never mind. So we create our prototype. It takes us 3 days. 3 days is unheard of in this industry. Like, it's super fast. These guys work hard. They were super smart. They know all the tricks. 3 days later, I get my prototype. It's a piece of software. It's what they call in Silicon Valley, you heard this term, I'm pretty sure, minimal viable product. MVP. Also the most valuable player, by the way. So I take my most valuable player, who happens to be the minimal viable product, I bring it to a customer. What does the customer say? Within 10 seconds, I guarantee you, it's happened all the time to me. They click on the prototype, and they're like, I don't even understand what this is about. And I'm like, oh, God damn it. So I take my prototype, I take the feedback, go back to my team and say, okay, here's the feedback, redo it. 3 days later, I get my second prototype, I bring it back to the customer, they get through the first screen. On the second screen, they say, I don't know what to do. I'm like, oh, screw it. All right, so I got so fed up by this that I said, this is not the way I want to do this anymore. This is not effective. This is not good prototyping, because it takes us 3 days to get through one iteration. And when you look at software, you realize one important thing. And this is true for software, and I show you later, by the way. You can prototype anything. You can prototype software, of course. You can prototype physical products, of course. But you can also prototype service interactions or human interactions. You will see in a second. But in this case of software, you realize when you just think a little bit about software, software is a lot like a comic book. Right? It's like one screen leads to the next. It's like in a comic book where you have like one panel to the next. You say, if I tap on this, in Tinder, I swipe left, and then another picture comes up. I swipe right. I don't actually know if that's the right.
It's a great tutorial.
I don't actually know how Tinder works.
I'm taking notes right now.
So, whatever. Like, so you swipe one way, like Jeffrey might know which direction, whatever.
I'll tell you later.
Perfect. You swipe one way, you get another person, and you get the idea, right? So what you realize, though, is that software you can actually prototype on an index card. You can literally draw out these screens. And it's much faster for me to draw those screens and program them. And then I can put them in front of a customer and can say, look at those, and they say, I understand or I don't understand. And here's what happened. This is a real-world story. This here is Castro Street 650 in Mountain View, just up the road, literally up the road from here. This is the Mozilla office. This is a Google Street View picture. This was my office. As you can see, I'm an important person. I have a corner window. More importantly, this here is Starbucks. And when you work for Mozilla and the Firefox web browser, you realize very fast that the people who walk into a Starbucks are your average customer, particularly in Silicon Valley, for sure. Like, the people who walk in there, they're the people who use Firefox all the day long, right? Or a browser. So what do? I go to my team and say, forget writing code. What I want you to do is I want you to draw index cards. It takes them an hour. You draw a stack of index cards. You go down. We went down to Starbucks. We asked a random person in line at Starbucks. We said, can we buy you a cup of coffee if you spend 5 minutes with us going through those index cards? And they said, of course, sure. True data. More than 80% of people said every single time, yes, of course. That's great. Why not? And then they went through the index card and they said, I don't understand this. And we said, oh, that's great. We took our index cards, we ran upstairs, we redrew the index cards, went downstairs again, found another person, put it in front of them. Repeated this over and over again. Here's what happened. We went from 0.3 prototypes a day. Remember, it took me 3 days to write one prototype, to 30 prototypes in a single day. I 100x'd my learning by simply going from high fidelity to low fidelity prototype. And this is important because you can prototype anything. You want to prototype a physical product? Build out of cardboard. That's what you're probably going to do today. You know, build it out of like whatever, like basalt wood or something. You want to or have to prototype something which actually has functionality. Use a computer, a mini computer like a Raspberry Pi or an Arduino. Your children can program this thing if it has to be. You want to prototype a service interaction. Super simple. Role play it. Play pretend, like your kids do this every day, all day long. They play pretend. You can do the same thing. You can go to a customer and actually walk them through a potential interaction, a solution. And again, the question you want to ask yourself, and the question I encourage you to ask and answer, and this might be the million-dollar question of this whole presentation, is this: is this really the quickest and cheapest way to test our assumption? Because I guarantee you, I've walked into so many meetings with clients these days, and I always walk in the meeting, I always ask this question, and the answer is always no. There's a cheaper, quicker way to test the assumption. And then it's always the response to that is, okay, let's do this. Right? So what we want to do now is a couple steps, and we're going to walk you through the prototyping step. But the first step is we need to figure out, now you know what your problem is. Now you have identified your monkey. We now need to figure out what is the possible solution. And how do you get to possible solutions? You do a brainstorm. And the way to brainstorm, you're laughing about this, right? Because like, if you hate brainstorms as much as I do, you know why, right? Because the brainstorm is always the same thing. You get whatever, like 5 people, 3 people in this group here. You get them together. There's always one person who happens to be the person who's always like, says, oh, I've got an idea, jumps to the whiteboard and starts writing. And then all the other people are quiet. And I never hear any of their opinions. We're going to hack brainstorming. I will teach you a way to do brainstorming which is significantly more efficient and significantly better and much, much faster. And again, if you're not taking anything out of this workshop, this slide and brainstorming will change your life. The way we're going to do brainstorming is this. You will sit down in your group of 3 individually and write down as many possible solutions for the problem, the monkey you have identified, as you possibly can. And you write one solution on a Post-it. One solution, one Post-it. One solution, one Post-it. And here's the important thing. First of all, you do it silently. So everybody gets to contribute ideas. Not just the person who's loudest or has highest status who happens to be at the whiteboard.
And at the end, if you have no Post-its, everybody knows that you came with no ideas to the table. And real quick, just to anchor this, to make sure we're clear on where we are and where we're going in this next step. So if you had this idea about eliminating household food waste, that's the problem. And then you told us a little bit about your first principles understanding, well, that there are these several opportunities, these several phases where that waste or that inefficiency, that loss can occur. And so then you think, well, what is the monkey? Well, I don't know what your monkey is, but maybe the monkey's something like, well, really the problem is getting people to be consistent throughout the week with their shopping plan from the beginning. So I don't know, maybe that's what it is. It's like humans have a hard time sticking to plan over time. Great. So in this next step, now we're going to think, what are the many ways that we might be able to address that challenge? And that's where you are now, coming up with a lot of possibilities for that, but not discussing them and not overthinking them.
Correct. And here's the magic. The way we run this, again, like this is silent, this is individual work. You write down one idea per, one Post-it per idea. And here's the magic. I will only give you 2 minutes. And there's science behind this, because here's what happens. You will see this. The first minute, the ideas will flow. Don't censor. Like, they can be as crazy as you want. Like, the first minute, the ideas will just flow. The second minute, you will feel that the ideas are coming a little slower. And what happens inevitably in minute number 3, which is the reason why we don't get into minute number 3, is you start censoring yourself. You start thinking, this is a stupid idea, or I shouldn't have written this, or this will never work. I want all the ideas. So we will give you 2 minutes to give you an idea of, like, you should get at least 10 ideas. Like, that should be easy for you. Push it and you get 20 ideas. Not as a table, individually, okay? So we give you 2 minutes. This is, by the way, also the part where if any of you is speaking, you have not understood the exercise. 2 minutes, time is up now.
3, 2, 1. All right, you can put those pens and markers down. Shake out that hand. I know it hurts. So many ideas. So many ideas. Shake out that hand. Raise it for me to make sure you're all listening.
Awesome.
Okay.
All right.
Fabulous.
So we're moving right next into our next step. So you have a whole bunch of ideas in front of you. Let's say we have done 10 each. What I want you to do now is this. Individually, you look at your ideas and you take the sanest one, the least risky one, the one you know will work, and the craziest one. And then you turn to your neighbor and you take those two ideas, and as a group of 3, you clearly have 6 of those now, and you briefly talk about them. You briefly introduce them. You say, hey, if we think about food waste, we could do let's say we can do an app which teaches you about food waste, or we can do this crazy sensor system which is in your house and tracks all your food and knows exactly where your food is, okay? And then as a group, you pick one solution, and it could be a combination, of course, which you want to prototype right here, right now. All right? So, as a group, again, and the reason why we want to take the sanest and the craziest one is, and again, like this is all rooted in science. The science shows us that innovation ideas happen to be on a bell-shaped curve. You have, in a bell-shaped curve, you have in the middle, you've got the safe stuff, you know it works, but it doesn't really move the needle. But it's okay because it's safe, high safety. And then at the edges, you have the crazy ideas. And the crazy ideas are either the complete game changer that changed the world forever, Steve Jobs craziness, or total crap, it will never work. But that's okay, because you need to figure out which one of those it is. And you want to go for the farther edges. And because we're prototyping, we should allow ourselves to try it out, because it's cheap, it's easy. So let's go for the edges and the one in the middle. And then figure out which one do we want to prototype right here, right now. So we'll give you 4 minutes. Again, for you individually, you take your Post-its, you say, this is a sane idea, like I know this could work, like I feel really good about this. And then you take one which is like, man, this is crazy, but somehow it would be awesome if we do it. And then talk briefly about them and figure out as a group, which is the one you want to prototype. 4 minutes. Go. All right, friends. Raise your hand if you can hear me. Sweet. Raise your hand and stop talking if you can hear me.
Yeah, I really like the people that put the hand up and then you just keep, you get pretty good at it. By day 2 or 3, you can have your hand up for like 15 minutes while you chat with your neighbor over coffee.
Okay.
All right.
Time to prototype. Now you have an idea. You have a proposed solution. You've got your hypotheses. We've got it validated through first principles thinking, the 4 Ps, all that good stuff. By the way, we are only about 15, 16 minutes into our experience. Now we're getting into prototyping. Prototyping, let me give you a couple ground rules. First of all, we give you ample amount of time. You will get an astonishing 10 minutes to prototype. At the end of those 10 minutes, I expect a fully functional prototype we can actually experience. Of course, come on. The way you want to think about prototyping is this. First of all, I highly recommend spend about a minute to talk about how do you actually want to prototype this thing, and the rest of the 9 minutes to actually prototype. Often, every once in a while, every once in a while I see teams, they're working like 8 minutes talking about like, how do we solve this? Like, what could we do? And then they're like totally run out of time. And again, this is all about experiential learning. You learn so much more by doing these things. So spend a minute, then start prototyping. When you think about prototyping, the easiest way to think of prototyping is think about the steps your customer needs to walk through. It's a little bit like if you're a movie director. You go from like one frame to the next. You explain to, like, in your head, you explain to someone, how does they actually go through our prototype? What are they experiencing? Put yourself into your customer's shoes. It makes it so much easier to prototype the thing. Also, you have to consider the environment. So as you will have, ultimately, like someone going through your prototype and testing it, think about what does the environment look like? Are you in a bank? Are you in your home? Are you in a hotel and trying to like swipe your, your card at the elevator, which doesn't never work, which is so weird. Whatever it is. And then the other piece here that we want to make sure you know now is that we're going to build in some accountability here. So at the end of your rapid prototyping, we're going to test these things. So you are going to share and present your prototypes to other people in the cohort. So that's thing 1. And thing 2, of course,
is that these have to matter. So at the end of the day, we got permission from SU. They will withhold your fancy diploma or whatever you get at the end of this whole week if your prototype does not pass muster at the end of this session. And
Just
we will
saying.
judge arbitrarily and unfairly, so expect that. You have 10 minutes to get in there, get crazy, get creative, have some fun, and actually learn by building the thing.
And use all the materials you can find. Use anything you find in this room which is not, nailed to the ground. It's all yours. Friends, the time has come. Raise your hand if you can hear me. I know, it's not enough time. Of course. Friends, if you can hear me. All right. So this was 10 minutes. I know it's brutal. But here's the important thing. As Reid Hoffman, the very famous VC here in Silicon Valley, the founder of LinkedIn, the current, chief innovation guy over at Greylock, once very famously said that if you're not embarrassed by the first version of a product, you have launched too late. I hope you're sufficiently embarrassed what is in front of you. Good, because now we want to get into testing, right? We want to get our prototype out into the world. We want to actually test it. And before we test, we want to make one important kind of a public service announcement.
Yeah, I think there's a big misconception about testing that we're just going to address head on. Also to make sure you understand the value of even testing with a really small group like you have here. You don't actually need that many interactions, that many tests to actually be able to validate your hypothesis or invalidate it, right? To learn the thing you want to learn. So this is a quote from Jacob Nielsen, who is one of the foremost usability and user testing researchers in the world, and he emphasizes here that elaborate usability tests are a waste of resources, that the best results come from testing no more than 5 users and running as many small tests as you can afford. So that basically, if you're trying to get something into the hands of dozens and dozens and dozens of users, you're probably running a really inefficient testing and prototyping process. And you're not maximizing the learning because you're spending too much time between iterations. And in fact, the way that this bears out is really nicely captured in this graphic, where you can see as you're getting to greater certainty, right, on that vertical axis, as you increase the number of users involved in the test, that you get to about 85% certainty when you've only run it in front of 5 users. And everything beyond that is probably getting a level of fidelity and a level of certainty that's not required to move on to the next step. That you're better off running more iterations closer together and cheaper to move the thing forward more quickly.
Indeed. And there's a second part to that, which I think is really important to also understand as you're putting yourself out there. By the way, we just debunked one of the biggest myths of Silicon Valley, which is you need to run huge user groups. Like Google famously tested the particular shade of blue on like hundreds of millions of users because they could. You don't need to do that. It actually doesn't help you. But there's a second part on this, which is the relevance of asking the right question. And this is another one of my personal stories. I used to work at eBay back in 1998, when eBay was like king of the hill. And when I was at eBay in Europe, we were everywhere, literally everywhere. And we were doing really, really well. Until one day, this pesky little book reseller called Amazon came on the market and decided to start to sell on their platform used DVDs and books and media titles. And what we saw was that their revenue, we saw their numbers, like through our market intelligence, we saw their revenue soaring, whereas ours was flat. So what do? We try to figure out what is the monkey, what's the problem here? What do we need to change? And we thought it was the checkout process. Because the checkout process at eBay, you remember eBay is an auction site, was pretty convoluted, whereas on Amazon you could just like one-click buying, it's really nice and smooth, right? So what do we do? We do what every good company does, we do user testing. User testing in the world of software looks like that. You're in front of a single-sided mirror, or behind it technically. You get someone into the room, you say, here's a task. We want you to do this task, and we observe you, and you speak out loud what you are seeing. What do? We get users in there, we give them $50. We say, go on eBay, buy a DVD, let us know what happens. We run this test for 2 days. We had like a bunch of people coming through. We couldn't see a pattern. It was like absolutely inconclusive, made no sense to us. So, You know, at the second day, I'm sitting there, I'm scratching my head. I'm like, man, what is happening? We can't figure it out. Until a colleague of mine comes in, observes one of those tests and says, you're asking the wrong question. I said, what do you mean? Like, it's an obvious question. Like, you go on eBay, you buy a DVD. What's wrong, right? He's like, no, you're asking the wrong question. Let me show you. So he takes the 50 bucks from me, goes to the next person who walks in the room and says, go online and buy a DVD. What do you think happened? Person takes the 50 bucks, goes online, types in amazon.de, goes on Amazon, buys a DVD. And we're like, afterwards, we go to the person, we say, why didn't you go to eBay? You know that this is an eBay test. You know that we are eBay. And he looks at us with big eyes and says, you guys sell DVDs? So what we thought was a checkout problem, and we assumed in our question was a checkout problem, was really a question of marketing, awareness, right? So be very careful of what the question is you ask of your users. It's really important to actually spend cycles on figuring out what is the right question to ask. Now we want to give you one last chance to actually do something before we wrap.
Yeah, and we cannot give you, Jacob Nielsen would be horrified, we cannot give you 5 users. I've been sitting out in the street trying to get people to come in all afternoon. No dice. But what we can give you is the 3 other people at your table that are not in your group. So we're going to give you the next 6 minutes, and you're each going to take half that time. You have 3 minutes to share your prototype, ask the questions you want to ask, solicit some feedback from the other group, see if they even understand what this thing that you're building is, and if it does the thing you're hoping it will do, then we'll switch you so the other group gets feedback, then we'll bring you back. So it is time to test. You have some users. Let's get to certainty. All right. Aaron is telling me we got to wrap it up. No, you should have already switched. Yeah. Oh, you're so kind. You gave your friends no time. We got to wrap them up. You can do it over dinner.
Friends, raise your hand if you can hear us.
All right, get a
This
right
is
hand
the
up.
last push we're going to do for today. We will give you all the energy. We'll give you a little bit more insight.
Get a left hand up. Now bring them both together. Yeah, we're almost done. You'll get to clap in a minute. Okay, fantastic. I know that was super quick. I know you didn't get a lot of feedback, but you got a little bit of feedback, and hopefully you got a flavor for testing and for this idea of running a very, very rapid prototype. And we're going to talk now about why it matters that this stuff goes so quickly. And it comes down to this idea, again, of driving learning, building a system that facilitates rapid learning through doing. And what we're working towards here, through these iterations, through this testing, is what we call rate-based learning. This is the goal, what we're trying to get to. This is why you want to run lots of cycles. You can think about it a little bit with kind of an analogy here, that if you're rolling a die and you want to get, let's say you want to get a 3, you know you've got like a 1 in 6 chance, right? And if you only get to roll it once, well, then your odds are not particularly good, right? But if you get to roll it multiple times, well, every additional roll of those die that you get, you're effectively increasing the likelihood that in aggregate, you're going to get the outcome that you want. So what we're trying to do here, by increasing the rate of experimentation and the speed at which we do it, is to drive ourselves further up that learning curve. And this is also why you want to be asking yourself at every step, is this the fastest, cheapest way that I can validate this knowledge, that I can test this hypothesis? That's what it comes down to. So that ultimately, we're rolling 10 die, 20 die, and also, these are not totally independent events. As you go, every experiment, every iteration, you should be learning so that the likelihood of rolling that 3 becomes even higher, right? You're effectively, instead of working with a 6-sided die, maybe you get to a 5-sided die. Maybe you get to a 4-sided die. And eventually, you get to a much higher statistical likelihood that you are going to achieve that end result that you want. But you only do it if you embrace this idea of fast, cheap, and at this point, vaguely out of control.
Who here has a budget responsibility in their respective company? A lot of you? Budget, use some form of budget. Here's the thing. If your people come to you and say, I want to try something out, I need, let's say $10 million, you should fire them. Like, really, seriously. What you want to have is you want to have someone coming to you and saying, Pascal, I need $50,000 because I want to try something out quickly, and then I need another $50,000 to try it out again and again and again. Because I can't stress this enough. In Silicon Valley, your chance of success in a startup is less than, what, like 2%, 3%? If you get a chance to roll that die over and over and over and over again, your chance of success increases truly exponentially. So give yourself the chance to succeed by running these prototypes. And if all of the stuff you've just experienced didn't convince you quite yet, I encourage you to check out a paper which was published at Northwestern University. This is an absolute breakthrough paper, come out only about 6 months ago. The paper is rather dully called Quantifying the Dynamics of Failure Across Science, Startups, and Security. We're going to send you the link, of course, to it. It's a really fascinating study. It's done by a guy called Dashan Wang. And what he did is this. He looked at and analyzed, using AI, 776,000 grant applications. He looked at 58,000 startups, and he looked at more than 170,000 terrorist attacks. And what he tried to figure out is, what is the common denominator of these events, these successes, these things either being successful or non-successful? And it's the biggest study we've ever found, and it has a really interesting implication. Because what he found is this, that failing fast, remember, rolling the die, being rapidly in your prototyping efforts, isn't just prescriptive, meaning you can tell it afterwards. You can say, oh yeah, sure, they tried this out and we know. It is in fact predictive of future success. I can walk into your company today and can look at your company and say, how many times are you actually trying something out? How many times are you basically rolling the die? How quickly are you in your rapid prototyping, and can predict your future success based on that? And that's really, really, really fascinating. And the 3 main pieces out of that study is this. 1, the extent you learn from previous failures. Because remember, nobody likes to fail. It's not about failing, it's about learning. And the extent you actually incorporate the learning from failure to failure. And that sounds very obvious, but I guarantee you, many teams actually don't do this very well. The military does this very, very well. If you ever want to get a crash course on this, ask Stephanie about the after-action review, which is done in the military, and like fighter pilots, like that standard procedure. It's the most important thing of any exercise they're doing. The second one is then, how do you apply that knowledge going forward? Clearly, like, you know, it's not enough to just learn. It's clearly you need to apply it. And then the third one is the number of attempts. Those 3 factors determine how successful you are in your innovation efforts. So truly, it's not about failing fast. It's actually about failing faster and faster. So increasing your rate of learning to eventually succeed. That's what this is all about.
And 3 things kind of in closing on that. 1, that should suggest that now is a great time to also be evaluating the metrics within your organization that you associate with innovation. And if you're not thinking about metrics oriented around learning and around experimentation, you should be. This is a great time to start doing that. And 2, while we've emphasized throughout this whole thing the importance of speed, of being fast with all this, you still have to take a little bit of time to reflect in order to learn. So part of running a good experiment is having some time to evaluate after the fact. This is that after-action review. Well, if it's a failure, what went wrong? And how do we maximize learning from that so that the next iteration is as rich as it possibly can be? And then you have to get to that next iteration, because this is ultimately the most important thing, and this is what we're going to leave with, the idea that action leads to insight more often than insight leads to action. So ultimately, this is all about learning by doing. The doing is important, and ultimately it is the key to learning fast and being adaptable and agile.
And as a very last thing, turn to your neighbor and give them a high five, because you just built a prototype out of nowhere in 30 minutes. You've done it.
It's kind of great to see back to the world of high-fiving again.
I know.
It's nice.
And this concludes our rapid prototyping session. We have a wonderful dinner. Jeffrey and I will hang out for the dinner, and we'll get you back. Aaron.